page 315, number 8. Okay, so let's see. Let me kind of give a rough sketch of these pictures. We've got that guy, and then we've got this guy. And this is R, T, S. And this one is X, Y, Z. It tells us up at the top there that triangle R, and this is important, all right? The order, and I'll show you what I mean here in a second. RST is congruent to triangle XYZ. Okay, and I'm going to label this a little bit different than what's in the book because I don't want to smoosh it. We'll do this top one the same way. X plus 21. This one I'm going to kind of put an arrow here and stick it out here. 4y minus 10 degrees. And then this angle right here, we've got labeled as 3y plus 15. And this side segment is 2x minus 14. And so for number 8, we're expected to find x, right? Other than the old joke, which was probably never funny, that says, there it is. Other than that, let's take a look at how to do it. So, and the important bit here, and they really only give us so much information on this particular problem, and so it's kind of obvious, but if this diagram was packed with more stuff, like we had stuff on each one of the angles and each one of the sides and whatever, our order over here, it kind of matters, or not kind of, it matters what we're looking at right here. Because basically we're saying that R goes with X and that S goes with T, S goes with Y, and that T goes with Z, right? Okay, so that's those go together, which means that segment RS and segment XY, and the word for go together there is corresponding. That's, the corresponding parts of congruent triangles, right? And so it tells us that these are congruent. So we're basically using CPCTC, the fact that corresponding parts of congruent triangles are congruent. So in this example, we're looking at RS here, RT. I don't know why I said RS. RT, which goes with XZ, right? Again, it's kind of obvious because it only gives us so much information of which ones would go together. But if there were more stuff there, then this is how you tell. You just match it. You just match the segments with this segment with that segment. So in this case, we are talking about that this is congruent to that. So we need to set up an equation to solve that thing. So if they're congruent, what would our equation look like? Well, what's congruent? Another way of saying pictures are congruent. What are numbers? What does congruent go with? What other symbol does it go with? Yeah, it goes with equal sign, right? So if they're congruent, then that means their measures are equal, right? And so in order to set up an equation, we just say this equals that. And it's really that simple. We just say that x plus 21 equals 2x minus 14. And then we've got a little baby algebra equation that we can solve. So how do we solve this little algebra equation? I'm holding. Well, hold on. We can't quite do that. You're on the right track, but you're missing the fact that there's an equals in the middle. So in order to move this guy over there, we can't just add it. How would we have to move it over there? True, true. We got to subtract 2x. If we do it on this side, then we'd also do it on this side. So minus 2x. So that would cancel. So then x minus 2x is what? Now you're adding again. Because we've got, right here, we've got 1 minus 2. And 1 minus 2 is not 3, right? But negative. Because the bigger one's negative, right? Right. Yeah, negative x plus, we're just going to bring down the things that we haven't touched. Negative 14. Now what would we need to do? Excuse me. Okay. Absolutely. Subtract that 21. So we've got, I'm going to put it up over here. Negative x equals, so negative 14 plus negative 21. What's that? Oh my goodness. Slow down. I agree. Negative 35. We got to get rid of one more thing, and that's this negative right here. We don't like that. So how are we going to get rid of that negative right there? Absolutely. We're going to divide both sides by negative 1. That's exactly right. So we're left with x equals positive 35. Does that make sense? Easy peasy, lemon squeezy. Good.